Hello student, my name is Wankhede and today I am going to explain you resource allocation graph which is used to help you to detect the deadlock. So basically what is graph? This graph is used to detect the deadlock and it is called as system resource allocation graph. This graph consists of two elements. One is the vertices and second is the edges. The vertices is of two type. One is the processes. It can be a number of processes and the resources. Along with that, it consists of the edges. There are the two edges, one from process to resource and one is from resource to process. Now, the edge which is from process to resource is called as request edge, and the edge from resource to process is called as assignment edge. In this graph, you can see that from P1 to R1, it is the request edge, and from R1 to P2, it is the assigned edge. It means that resource is assigned to P2, and from P1 to R1 it is the requested. It means that that process P1 is requesting for the resource R1. Now, in the diagram, in the graph, the circle represent the process and the square rectangular boxes represent the resources. Now, the resource can be of one instances of resource, that is denoted by a single dot. It is that is shown in R1 dot. If the multiple copies or multiple instances of resources are there, then multiple dots are being mentioned. As shown in the diagram, R2 with three instances. The resources can be anything. It can be an input device, it can be the output devices, the printer and scanner. So for example, the R1 dot means it is having the only one input devices. R2 with three dot means it is having the three printers in that. Now, whenever the process want to request for the resources, it first requests that resources by giving the arrow as shown in the first diagram. From process to resource, it means that that process is requesting for the resources. As soon as the resources is allocated to that process, the arrow get reversed as shown in the diagram, second diagram. From resource R1 to process, the arrow is shown. It is get reversed, that resource is allocated to assign to the process. As soon as the resource is no longer used, that edge get deleted, removes that edge. So in the third diagram, there is no edge. So in this diagram, we can see that there are three processes denoted by this circle P1, P2, P3. There are four resources denoted by the rectangular boxes, that is R1, R2, R3 and R4. The edges are from P1 to R1, P2 to R3, R1 to R2, R2 to P2, R2 to P1, R3 to P3. The resources R1 is having only single instance of resource, R3 is having only single instances of resource, R2 is having two instances of resources, and R4 is having three instances of resources. Now, what the diagram is showing that from process P1, P1 is holding the resource R2. You can see that arrow. That arrow is from R2 to P1. It means R2 is assigned to P1 and P1 is requesting for R1. Similarly, P2 is holding R1 and R2. It is waiting for R3. P3 is holding for holding an instances of R3. Now, for what reason we are using resource allocation graph? To detect the deadlock. So in the graph, if there is no cycle means from if you are starting from one point and you are reaching to that point itself, then there is no deadlock. There is no cycle, no deadlock. But if there is a cycle, then there may be a deadlock or may not be a deadlock. So in simple thing, if there is a cycle, there is a deadlock, may or may not. And if there is no cycle, it's confirmed that there is no deadlock. So this is an example of the graph with deadlock. Now, we have to first find out whether there is a cycle or not. So yes, in this graph there is two cycle. One is it start from, we just need to go to the path. So from P1 to R1, then P2, then R3, then P3, then R2, and again reaching to the P1. This is one large cycle. The second cycle is from P2 to R3, then P3, then R2, and then R2. It is a small cycle. So there is a cycle. So I said that if there is no cycle, confirm it is that it is no deadlock. But if there is a cycle, then may or may not have the deadlock. Now, we have to check that the deadlock is there or not. The first we have confirmed that there is a cycle, so there is a deadlock. But what is happening that it is having the characteristics of hold and wait. This is the one characteristic of deadlock. If that characteristic is present, then deadlock is present. So you can see that P2 P2 is waiting for R3, and P2 is holding R2, and R3 is being held by P3. Hold and wait. P2 is holding R2 and it is waiting for R3, which has been allocated to P3. That is one problem. P3, it is waiting for P1 to release the resource R2. Since it is being used by R3, P3 is having R3. So it is having the hold and wait. So it is confirmed that there is a deadlock. In next example, we will see that deadlock is there or not, cycle is there. So there is a like second example. Now here there is a cycle. It starts from P1 to R1, then P3, then R1, again P1. This is the cycle. And I told you that when there is a cycle, may or may not have deadlock. In the previous example, there is a cycle, but there is a deadlock. Now, in this example, there is no deadlock because we can see that if this P4 is not holding any resources, it is okay, it is holding R2, but it is not waiting for another resources. So P4 can release the resources. So as soon as the P4 get release that resources that R2 will have available, P3 is demanding for R2. Since that is available, so P3 can use. After use, P3 can remove that edge. So as the edge was removed, the cycle was get removed. Okay. So what is that? P4, if P4 release the R2, that edge will be deleted. As the edge was deleted, R2 is having the copy, P3 will be allocated by the R2. As soon as the P3 works was completed, this edge get deleted. As the edge get deleted, the cycle get deleted. So as there is no cycle, no deadlock. So in this example, we can say that this is the graph with cycle but no deadlock. And in the previous, we can say that this is the graph but there is a deadlock because there is having the hold and wait uh, concept. So it is not removing that part. So in the conclusion, we can say that if there is no cycle, no deadlock. But if there is a cycle, then may or may not be deadlock. And the source allocation graph is just used to confirm you that that graph consists of process with having the deadlock or not.